Today, let us see the converse of tangent theorem. See the statement, a line perpendicular to the radius at its point on the circle. This is the first part. And in diagram, we have to show that line taken perpendicular to the radius at its point on the circle. N point of that radius is on the circle and line L is given perpendicular. So we can mention in the given M is the center of the circle, L is perpendicular to the radius at the point which is on the circle of that radius. N point is on the circle. So this line L is perpendicular, that is given at its outer end of the radius. We have to show that it is tangent to the circle. That line is tangent to the circle. For that you must remember the tangent. What about the tangent? It is touching to the circle in single point. Circle and tangent. What is the relation? There is single common point between circle and tangent. We have to show that N is the only one point which is common between circle and the line L. So let us see that L is perpendicular to the radius at its outer end, that is given there. Now you can take any point on the line L. Suppose it is P and you join MP. So that is your first step. Take any point. Take any point P except N on the line L. Excluding N, we select point P on the line L and we join that segment MP. And we know that angle MNP is 90. It is given. MNP is 90. So you are getting triangle MNP, right angle triangle. So you can write that, but angle MNP is equal to 90. This is given. Therefore, triangle MNP is a right angle triangle. And MP is the hypotenuse. So you know that property of right angle triangle, hypotenuse is always greater than the remaining each side. So definitely MP segment, that is hypotenuse, must be greater than segment MN. Segment MN. It is property of right angle triangle. It is a right angle triangle in greatest side, hypotenuse. So you can see that MP is greater than MN. MN is the radius of the circle. So definitely P lies outside the circle. Point P lies outside the circle. It means it is in the exterior of the circle. So you can see that each point like P on the line L is outside the circle. So only single N point is common there. Therefore you can draw the conclusion. Therefore N is common between circle and line L. And if single point is common there, N point is common there, so L is the tangent to the circle. Therefore, line L is tangent to the circle. We can draw this conclusion. This is known as converse of tangent theorem. This is known as converse of tangent theorem. Okay.